Hello friends, now we are going to start chapter number 5, that is all about electromagnetism. Now before starting the electromagnetism, I hope you know what is the magnetism. What is the magnet? You must have seen small permanent magnets. I said permanent magnets, not electromagnets, in your house. Like we attach some cartoon characters to our fridge with the help of some permanent magnet. You know that black colored chips are there, round or square, which are attached to the pictures, and then we attach those pictures with the help of magnet to our cupboard, fridge or whatever things. So these are the permanent magnet. Permanent magnet means the magnetism induced in it is permanent. Okay, it is not depend on whether it is kept in the electric field or not. These are generally of black color or white color, shine like steel. On that some coating is done. So these permanent magnet you get in different sizes and shapes. But you must have seen these magnets are very small magnets. Making huge permanent magnet is difficult thing due to size and the process. And in some cases we require temporary magnetism. We are going to see this, what is the temporary magnetism, in this chapter all about electromagnetism. This temporary magnetism induced is called as electromagnet. In our childhood we have played lot many games with small magnets, permanent magnets, and we also know that any magnet has got two poles. One is the south pole and one is the north pole. We also have played game like attaching two magnets. Okay, you know that whenever the opposite poles comes closer, they attract each other and they stick to each other, two magnets. But when the similar pole comes close to each other, what happens? They repel each other. We might have played some games like touch the magnets. If the magnet is very powerful, it will not touch, or you will need a lot of force to touch the same poles. But in case of opposite poles, they stick to each other immediately. Okay, electromagnets, you might not have known that there is a electromagnetism in the many instruments we use in our house. Now what do you mean by electromagnet? The electromagnet is a temporary magnet. Okay, now have you seen electromagnet in your house, or have you seen the phenomena of electromagnetism in your house? Definitely yes. You must have seen the speakers, radio, television antenna. All these things works on the principle electromagnetism. Now we will see what is electromagnetism. But before going to electromagnetism, first of all we will see what are the magnetic lines of force and what is the magnetic field. We will do a simple experiment, that is we will place a magnet. Suppose this magnet is placed here. Okay, you know that the north pole is generally shaded with the red color. Now this is my north pole and this is my south pole. Mind well, this is a permanent magnet. Okay, now if I drop some iron foils, very small particles of iron, what will happen? The figure is given in your book. Please refer to figure 5.1. Now when I put the iron fillings over this or around this on the paper, and when I tap the paper and allow the iron fillings to rearrange themselves, what will happen? The iron fillings will have a permanent shape. It will have permanent shape. It will have some shapes like this. Okay, that means the magnetic field is there around us. The iron filings are very dense near to your magnet, and it gets diluted when you go away from the magnet. Okay, the figure 5.1 shows you the actual photograph of the iron filings put on the permanent magnet. Now these are called as the lines of forces. That means this is the field of attraction for this magnet. Now suppose a second magnet is, or any iron material, or suppose a nail is put here away from the magnet, it may not get attracted. But as soon as it enters the field, magnetic field of that magnet, it will get attracted towards the magnet. Okay, so this is called the field, the magnetic field of this magnet. Now this magnetic field is permanent. Okay, now how this line goes, that we will see. Now in this experiment we will try to plot the magnetic field lines, that is the magnetic lines of forces. What we will do, we will again take a sheet of paper on which we will place a permanent magnet, of which north pole is here, south pole is here. After taking this, I will first mark this or outline, make an outline of this bar magnet on the paper. Then I will take a compass. You know what the compass means. There is a magnetic needle. North pole is shown there with the red mark, and this will always show you the north direction. Now I will put this compass at several places here. Okay, starting from north pole, I will go to south pole. Each time I will allow that needle to be settled. I will mark that north with the pencil point. At the end, I will find that I get a smooth curve from north end to south, from north to south, because that needle, magnetic needle, will always show you the path. Now suppose if I repeat this experiment many times, what I will get? I will get such curves, and on the other side also I will get such curves, and on this side I will get such lines. Here it will be marked outwards, and here it will be marked inwards. These are the arrows of magnetic compass. Now you will see some figure like this. Now just remove the bar magnet from the paper. It is already traced on the paper, and you will see such a smooth curves on both the side of the magnet and also on the edges of the magnet. These lines are called as magnetic lines of forces or magnetic field lines. Okay. Now let us see the properties of these lines. The first property is these are closed lines or closed curves, which starts from the north pole and go to the south pole. I am writing in short form because generally whenever we are writing notes, we have to remember some points. We generally write in short forms, so it is easier to remember. Okay, so they start from the north pole and go towards the south pole. The second property is the tangent shows tangent at any point shows direction of magnetic field. You take tangent at any point on these lines of forces, it will show you the direction of the magnetic field. The third property is no two lines, these lines never intersect each other. These lines of forces never intersect. Never intersect each other. Okay, and the fourth property, these magnetic lines of forces are crowded where the magnetic field is strong. Crowded where the magnetic field is strong, and those are far away, far where the magnetic field is weak. That means if you go away from the magnet, the lines of forces go away from each other, as I told you before, and near to magnet, that means where the magnetic field is very strong, these lines are crowded. Those lines are very close to each other. So these are the properties of the magnetic lines of forces. Now I am talking about the compass, or we did an experiment with compass. You take any bar magnet or any permanent magnet. If you hang that permanent magnet, suppose this is a permanent magnet. Suppose this is a permanent magnet. If you hang that permanent magnet with the thread in between and you let it rotate freely, what will happen? It will rotate and it will stand still at a particular direction. Okay? The end, which is towards the north of the earth or towards the north direction, is called as the north pole of this magnet, and the other end will be called as the south pole of this magnet. Actually, the earth is reversed. Wherever it shows wherever we call it as a north pole, it is actually south of the earth and it is a north of the earth. So the opposite poles attract each other, and we say that this is the north pole, this is the south pole, and in general wherever the north is marked, we say that is the north direction and that is the south direction. Okay, now this is about the permanent magnets. Now let us talk about the electromagnets. What is electromagnet, or what is the electromagnetism? Let us see that.